Geometry proofs. Just hearing that phrase can make you a little nervous, right? But what if I told you there's a pattern? A simple, repeatable system that every single proof follows? Today, we're going to break that pattern down and give you a method to tackle any proof with confidence. Okay, let's get into it. Does this look familiar? Yeah, I thought so. You get the given, you see the prove, but that big, empty space in the middle, it just feels impossible. This is probably the #1 feeling students have when they're staring down a blank proof. And listen, if that's you, you are absolutely not alone. That proof writing panic is a totally real thing. But it's also something we can totally overcome with the right tools and a solid strategy. So the goal today is to turn that panic into a plan. So before we even write a single line of a proof, we got to build a solid foundation. Let's start with 4 foundational rules that are going to help you dodge the most common mistakes right from the very beginning. This is it, the classic 2-column proof. And honestly, it's way simpler than it looks. The left column, statements, is for what you know. The right column, reasons, is for how you know it. That's the whole game. Every single statement has to have a reason. Next up, let's clear up something that trips up so many people: equality versus congruence. Think of it this way. The equal sign is for numbers, things you can measure, like length or degrees. The congruence symbol, that squiggly little guy, is for the actual objects themselves, like whole segments or entire triangles. It's a small detail, but it's a super important one. Okay, this rule is huge. A diagram is not evidence. I'll say it again. A diagram is not evidence. A triangle might look like it has equal sides, but if there are no markings or it wasn't in the given info, you cannot assume a thing. You have to rely only on the facts you're given, not what your eyes think they see. So let's recap our foundational rules. 1. Always start by writing down your given info. It's a freebie. 2. Know your destination. What are you trying to prove? 3. Every statement needs a backup, a reason. And 4. Always draw the diagram so you can see what's going on. These are your non-negotiables. Okay, so if every single statement needs a reason, where do these reasons come from? Well, you actually have a whole toolkit full of them. Let's open it up and see what we've got to work with. Your toolkit of reasons basically falls into 5 big categories. You got your givens, of course. You have definitions, like the definition of a midpoint. Then there are postulates, theorems, like the one for vertical angles, and properties, like the reflexive property. These are the only tools you're allowed to use to build your case. Now that we have the rules and we have the tools, we need a game plan. How do you actually attack the proof and start filling in that blank space in the middle? The best strategy is to attack it from both ends. First, you work forwards. You take your given info and ask, okay, what does this tell me? What's the very next thing I know for sure? But then, and this is the pro move, you also work backwards from what you need to prove. Ask yourself, to get this, what would I need right before it? And very often, the answer is right there where those 2 paths meet. This might just be the single most important practical tip for geometry proofs, seriously. Every time you write down a statement that 2 sides or 2 angles are congruent, you have to immediately mark it on your diagram. It organizes everything visually, and trust me, it often shows you the exact path you need to take. All right, enough theory. Let's put this whole system into action. We're going to apply all these rules and strategies to a real proof, and you're going to see how it all just clicks right into place. So here's our problem. We're given that point C is the midpoint of 2 different line segments, BE and AD. Our goal is to prove that triangle ABC is congruent to triangle DEC. First step, it's the easiest one. We just write our statement, C is the midpoint of BE and AD. And the reason? Well, it was given to us. Boom, 1 line down, 0 stress. Okay, and what's our golden rule? If you write it, you mark it. We just wrote that C is a midpoint, so we immediately go to our diagram and mark it up. We can put some tick marks on there to show that the segments are split into equal halves. See, the diagram is already starting to tell us a story. So because we know C is a midpoint, we can now make 2 new statements. We know that segment BC has to be congruent to segment EC. And we also know that segment AC is congruent to DC. The reason for both? Simple. That's just the definition of a midpoint. We're just explaining what our given actually means. And now we follow the rule. We wrote it, so we mark it. We'll add a single tick mark to AC and DC and some double tick marks to BC and EC. Now let's take a look. We have 2 pairs of congruent sides. That's S, S. So what else do we need to prove these 2 triangles are congruent? If you look really close at the diagram where those lines cross, you should spot them, a pair of vertical angles. So we can state that angle BCA is congruent to angle DCE. And our reason is a theorem straight from our toolkit. Vertical angles are congruent. Time to mark up our diagram again. We'll add those little angle arcs to show they're congruent. And now, look what just appeared. We have a side, an angle right between them, and another side. That is the side-angle-side pattern. We have everything we need. So we can finally write our last statement. Triangle ABC is congruent to triangle DEC. Our reason for that, the SAS congruence postulate. And we did it. We started with what they gave us, and step by logical step, we filled in that middle section and got right to our goal. See, proofs aren't just some frustrating thing you have to get through. They're actually a way of thinking. They train your brain to build a solid, logical argument, and that's the key that unlocks a much deeper and way more beautiful side of math. For example, once you master basic proofs, you can start to understand these incredibly cool and elegant ideas like Seva's theorem. It uses simple ratios to prove when three lines inside a triangle all meet at one single point. It's this beautiful piece of mathematical logic that starts with the exact skills we just practiced. So the system is all yours now. You have the rules, you have the tools, and you have the game plan. Proofs aren't a mystery anymore. They're just a puzzle waiting for you to solve. So the only question left is, what will you prove next?